Okay, everybody, we're working through the radicals chapter. And what we're going to do is we're going to apply the radical transformation to this linear function here. We're going to state the domain, range, intercepts, and of the image of the function here, and state the number of invariant points. Okay, so the first thing I want to do with you guys is we're going to just cancel that out, because anywhere where the function, and by the function I mean specifically the y-coordinates, anywhere where the y-coordinates of this function go to become negative, when I take the square root of that, they're going to disappear. Now, this thing is going to start right here, okay? And if I take a look at that, this is not a great scale here, but this is at -2.5 here. That's going to stay the same here. Additionally, this point right here is going to stay the same because the y-coordinate is 1, okay? Right along there, the y-coordinate is 1. The reason why that point doesn't change is because the square root of 1 is 1. So the square root of 0 is 0, square root of 1 is 1. Those 2 points won't change. So right now I can come over here and say that the number of invariant points, 2. Now, what is that graph going to look like? Well, I can do one more thing here to help myself out here. I notice that the y-intercept of the original function is 5. That means the y-intercept of my transform function is going to be the square root of 5, which is going to be somewhere here. I don't know exactly where, but it'll be somewhere there. Now, here we go. To draw this graph out, what's got to happen here is for this little section right here, the function has actually got to kind of bubble out above the line. The reason for that is when you take the square root of numbers like let's say 25, 36, 49, when you take the square root of those numbers, the square root becomes smaller. But when you take the square root of a fraction, it's actually the opposite. The answer gets bigger. So for this little section right here, where all of the y-coordinates are fractions, the square root jumps above the line. Now, from there, we hit the invariant point, and then we're going to go up, and now all of our points are below the line, and away we go. So that's basically what the function's got to look like. Your domain here, based on what I've drawn out here, is going to be x is greater than or equal to -2.5. At least that's what I'm reading that off as. And the range here will be y is greater than or equal to 0. The x-intercept doesn't change, so the x-intercept here is still going to stay -2.5. And my y-intercept will be √5. Okay, the y-intercept of the original was 5, so the y-intercept of the transform function will be the square root of that.